Hey guys, it's Miss Johnson here, and I'm here to talk to you today about our learning target for slope and writing linear equations. It says at the top of your notes page, the grade of the road is a percent that measures the steepness of the road. It is found by dividing the amount the road rises by the corresponding horizontal distance. So that would be the same thing as saying rise divided by a run. We look at rise over run as slope. The slope is the ratio of the change in the y-coordinates over the change in the x. Now, some of you may remember the slope formula as being y2 minus y1 over x2 minus x1. That's the same thing as saying the change in y over the change in x, or just like in the first little blurb we saw, it's rise over run. There's four different kinds of slopes that that lines can have. Some of them are pretty obvious. The first one being positive. A positive slope is when a line rises from left to right. So we read graphs just like we read books. We go from left to right. And in this case, my line is increasing or going up. So that would be a positive slope. And then I have a slope of 0. Slope of 0 is when my line doesn't increase or decrease at all from left to right. It stays horizontal. Horizontal line, slope of 0. These lines also have the equations of just y equals whatever the value is. These lines would be y equals mx plus b. A negative sloping line would also be y equals mx plus b. This is when the line decreases from left to right. So you can see if I start on the left and I go down, I'm decreasing from left to right. So that's a negative sloping line. And then a vertical line, we call that slope undefined because this is not a function here. This slope or this line has an equation of x equals whatever the x coordinate is. So like this one would be x equals -2. But any vertical line has a slope that's undefined. A couple other things about slope that you've probably heard in the past. Parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. So let's just look at our first example here. We want to calculate the slope of a line that passes through -1, 4 and 1, -2. So what I would do is I would drop that into the slope formula. So I'm going to say that this is my second point, and that's my first point. So I'd have -2, m equals, I should say, m is my slope variable, -2 minus 4 over 1 minus -1. -2 minus 4 is -6. 1 minus -1 is 2. This is going to be a slope of -3. So m equals -3 here. Why don't you guys go ahead and pause the video and see if you can do part B. Find the slope of those 2 points. Let's take a look at number 2. Graph the line with the given coordinates or the given conditions. The first one is a line that passes through the point 2, -1 and has a slope of 1/2. So in this case, I would plot this point on the line, 2, -1. I'm going to go right 2 and down 1. There's my point. Then my slope is 1/2. That means that 1 is my rise and 2 is my run. So I'm going to go up 1 and right 2. Remember that we can also go down 1 and backwards 2. It's good to have 3 or 4 points to connect that line just so that your line looks pretty accurate. And there it is. So there's our line there. In part B, we have a slope of -3 and a point of -3, -4. So again, I need to start with the point. -3, -4 is backwards 1, 2, 3, down 1, 2, 3, 4. So there's that. And then a slope of -3, that means it's a rise of -3 or down 3 and a run of 1. So I'm going to go down 1, 2, 3 and over 1. I'm a little bit off the coordinate plane, but that's okay. I could also go up 3 and back 1, up 3 and back 1. And there's my line there. There we are. So graphing lines given a slope and a point. Let's talk about rate of change. Rate of change is a measure of how a quantity changes on average relative to another quantity, which is often time. So it's the change in something divided by how much time has passed. Okay? Typically, time is our independent variable. Time is x, which means that we're going to have our time in the first spot and whatever the value is in the second. Okay? Now, time is always independent because we can't control it. We can't do anything with it. We can't slow it down. We can't speed it up. We can't back it up. We can't stop it, pause it. It just keeps going at the same pace it always does. So it's usually our independent variable. So then let's take a look at number 3 here. It says use the table that shows different temperatures at different times in the day. What's the average rate of change of the temperature from 8 a.m. to 10 a.m.? 8 a.m. to 10 a.m. So I'm looking here to there. So my first point would be that one, 8 and 36. My second point would be this one, 10 and 47. So I'm going to find the slope, use the slope formula to find the rate of change because that's what slope is. It's also a rate of change. So I can use the slope formula. That means I have 47 minus 36 over 10 minus 8. 47 minus 36 is 11, and 10 minus 8 is 2. So I have 5.5 degrees. Now, when we're talking about situations like this, we always have to label our answer. It's degrees per hour, our rate of change here. Okay, let's take a look at part B. Actually, why don't you guys go ahead and pause the video and see if you can find the rate of change in part B. I'm going to move on to part C. It says during which 2-hour time period was the average rate of change of the temperature the least. So what we want to look at is how much did the temperature change in each of those 2-hour time periods. So here we know that they changed 11 degrees in 2 hours. This 2 hours, it changed 8 degrees. This 2 hours, it changed 3 degrees. This 2 hours, it changed 2 degrees. These were all 2-hour increases. So the lowest one is from 2 p.m. to 4 p.m. That was the smallest average rate of change there. And then last example that we'll talk about today, it says Kevin's savings account earned balance changed from $1,140 in January to $1,450 in April. Find the average rate of change per month. So we have January to April. And if we think of how many months have passed, that means, or if we go from January to April, we have January, February, March, April. This is like 3 months have passed. So we need to figure out what is the average change per month. So I'm going to subtract those two, 1,450, 1,140, and 3 months have passed. I end up with $310 divided by 3, which is about $103.33 per month. Okay. So rate of change, talking about how much something changes over a period of time. So our average rate of change in this case is $103.33. All right, that's going to stop our video for today. We'll finish up the rest in class tomorrow. Thanks for watching. Don't forget to go back to Schoology and take your quiz.